All right, taking a look at example 2, find the constant of normalization c for which this function right here, a little close to the previous example, but cx e to the negative x is a probability density over the interval 0 to infinity. So remember, a function is a probability density function if, when you integrate it over the specified interval, it equals 1. So what we want to choose c so that the integral from 0 to infinity of cx e to the negative x dx equals 1. And I'm going to, okay. So let's go ahead and start with 1 equals. We're just going to continue with this equation. So 1 equals, and then let's run some integration by parts. The limit as r goes to infinity of this integral here, so 0 to infinity, we're going to replace this infinity with an r and then use a limit to push r to the limit. So we'll go ahead and run integration by parts. So for integration by parts, we can go ahead and choose u to be equal to cx, therefore du is c dx. dv is going to be e to the negative x dx, and v is negative e to the negative x. So this becomes 1 equals the limit as r goes to infinity, u times v, so negative x e to the negative x from 0 to r, minus the integral from 0 to r of v. So v is a double negative, so that plus, so the minus on the outside will turn to a plus, e to the negative x times our du, which is c dx. All right. Continuing here. All right, so we'll have negative r e to the negative r minus minus, so plus 0. Then if we integrate this, we'll have minus c e to the negative x between 0 and r. So continuing, 1 equals the limit as r approaches infinity of negative r over e to the r. I'm going to just drop that negative exponent and take it downstairs. Minus c e to the negative r. Minus minus, so plus c e to the 0. Of course, in the limit, this term is 0. If you're not sure about that, because this technically is form infinity over infinity, you can use L'Hopital's rule on this, and you'll get 1 over e to the r, and then that goes to 0. So that goes to 0. This term will also go to 0, and what survives is this term, because e to the 0 is just 1. So we have 1 equals c. So it turns out this function, p of x, x e to the negative x, is a probability density. Is a probability density on the interval 0 to infinity. All right.